Magandang araw po. Ako si Patrick, ang product manager ng SkyCiv load generator. Sa araw na to ay tuturuan ko po kayo kung paano gumamit ng SkyCiv load generator gamit ang NSCP 2015. Meron na kami ngayong seismic at windload, kaya yun ang ating pwedeng ma-generate dito sa tutorial na ito. So, ang unang step ay select yung NSCP 2015 and then click proceed. Uh, sa left panel, makita ninyo ang project details, site data, structure data, and etc. So, i-define natin lahat from top to bottom. And then, mamaya i-click natin calculate loads kapag okay na lahat. Unang step ay click yung site data. And then, select occupancy category. So, in NSCP 2015, meron tayong 5 occupancy category. So, if hindi kayo sure, pwede i-click yung I button dito para ma-view yung definitions ng occupancy category sa NSCP. So, dito, since ang purpose ng tutorial na to is magkaroon ng example sa pag-design or pag-generate ng wind at seismic load sa isang residential building which is two-story na bahay. So, two-story na bahay ay will fall under standard occupancy category 4. So, this one. So, select natin occupancy category 4. So, based yan sa table 103-1 ng NSCP 2015. And then, isa-select natin yung seismic source type. So, at most, sa Philippines, we have in type A. And then, some are B and then C. So, even if hindi natin define to, ang isa-select niya automatically ay yung seismic type A. So, for record purposes, i-select natin yung seismic source type A. And then, maglagay lang tayo ng address. So, ang lalagay ko dito ay San Marcelino, Zambales. Example location sa Philippines. So, sa Philippines, makukuha nyo yung basic wind speed based dun sa wind speed map sa NSCP at saka yung nearest fault or nearest major fault based naman siya dun sa approximate value na kinukuha sa PHIVOLCS. Actually, meron din siya sa NSCP 2015. Pwede siyang i-double check itong value na to sa Hazard Hunter PH. So, if pwede nyo i-edit tong distance na to and then pwede i-adjust itong near source factor NA at near source factor NV. So, itong NA at NV automatically na siyang kinakalculate based dun sa distance niya from the major fault in kilometers. So, dito, in this example, NA and NV is equal to 1. So, since okay na siya, yan, i-confirm ko na site. So, mapapansin nyo, nag-green siya kapag yung mga data is defined na. So, mamaya pwede tayo maglagay ng project details. Pero after na lang. Para sa report, merong project details pag print natin yung report. Next step is yung structure data. Click natin. And then currently, since ang meron lang sa NSCP ay building, select natin building, tapos select roof profile. So yung roof profile nung i-design natin ay monoslope roof with building length, which is this one, equal to 8 meters, and then building width, which is this one, 10 meters. And then mean roof height, ang lalagyan natin ay 7.8. Roof pitch angle, 15 degrees. Then, okay na. Pwede natin i-check yung 3D render for better scale. So, ito siya, if scaled yung dimensions. So, since okay na, click natin yung confirm structure data. So, the next steps are, define natin yung wind load or seismic load. So, since we will be generating yung both wind and seismic loads, unahin natin wind load. So, ito, checkbox siya. Kung ayaw nyo i-calculate, pwede nyo i-uncheck or check. So, since check natin siya parehas, check natin itong checkboxes. Select natin yung wind load. And then, uh, pwede tayong mag-specify na ng wind direction tsaka ng exposure category. Or pwede natin i-click ito, ang view wind design inputs for all directions. So, ang gagawin nito is, it will create upwind sectors para pwede natin i-define each wind source direction na kung ano yung, or mag-assign tayo ng exposure category for each terrain sector. And then, para makita rin natin kung ano yung para magiging approximate na pinaka-worst case na velocity pressure. So, since dito, since yung KZT, topographic factor, ay 1, set as 1. So, yung terrain ay mostly flat. Makikita natin na yung worst velocity pressure ay isa lang since lahat exposure D. So, by default, exposure D yung default value na exposure category doon dito sa table. But definitely hindi siya laging exposure D. So, we need to adjust that kasi para lang makuha yung worst case. Pero definitely, for example, this one, I can say na this is C. And then dito C. Ito pwedeng B. And then B. And then B. C. And then C. And then C. So, actually, it's based on a specific radius. So, pwede nating i-edit or i-adjust yung radius dito. Pero for simplicity, ito na lang siya. So, you can click the sector to adjust each exposure category or pwede nyo i-adjust din dito sa drop-down. So, for example, in north, gawin nating D. Mag-change din siya dito. Or balik natin sa C. So, after that, we can regenerate the table again. So, click natin yon. Since yun pa rin, kasi yun pa rin yung pinakamalaki yung velocity pressure, since pwede natin i-click na lang yung north. So, napansin nyo, KZ is changing because this one is, or this one, the values there depend on the exposure category selected. So, hindi siya lagi equal for all directions. So, you need to check that one. And then, topographic factor, especially. So, for upwind, meron siyang speed up na effect. So, since itong location is relatively flat surface or flat terrain, yung KZT ko is equal to 1. Pero if nasa bundok, definitely you need to, or in ridge or escarpment, you need to double check the speed up factor, which is the topographic factor. KD, since it's MWFRS, we will be designing MWFRS. KD is equal to 0.85. And then this one is 250 kilometers per hour for occupancy occupancy category 4 or 69.444. So you can already get the approximate velocity pressure, your worst velocity pressure. And then yung KZ pala is based on height or based on Z equal to 7.8 meters. And then next is select the structure type. So I said we will be designing the main wind force resisting system, and then select enclosure, maybe partially enclosed. So this one depende siya sa opening. So actually sometimes you need to double check scenarios wherein it is enclosed. So the forces will be generated, and then sometimes pag kunyari may nasira during the typhoon, magiging partially enclosed na siya. And then, pag nasira na yung iba, magiging open. So, may mga scenarios na nag-iiba yung enclosure classification. So, be prepared to check those cases or scenarios. And then floor elevation, this is used for windward wall pressure distribution. So, since we have two floors, pwede natin ilagay siguro we will distribute it per level. So, for example, second level, it is at 3.5 meters, and then at roof, it is 7.8 meters. Then, okay na. Just click confirm wind parameters. So, yun. You can see yung button, naging green na siya. So, uh, that means okay na yung valid yung mga input parameters. And then next is seismic load. So we need to select soil profile type. So yeah, these are the options. Let's say we select soft soil profile SE, and then this one is concrete. So CT ko is 0.073. So from that, since may H na tayo and may CT na, we can already get approximate fundamental period of the structure. This one is based on the 28.5.2.2 method A, but you can definitely use or adjust this one. If you use this S3D, you can get the period there, and then just put the period here. So for example, I'll just accept this one. And then the response modification factor based on tables 828-11 and 12. So by default, this is 8.5, which is for ductile concrete, SMRF. So you can definitely adjust this one. And then based on the soil profile type, the CA value and CV value will be calculated. So yeah, this one. And then actually this is automated, so you can adjust this one definitely. And lastly, the floor weights. So I mentioned earlier, we have two levels, and then the roof, second and roof, and then this one is 3.5 meters and 7.8 meters. The weight, we can just use 400 kilonewtons, and then the roof maybe 180. So this one, the floor weights data is used in the vertical distribution of the seismic force if you're using equivalent lateral force method. So yeah, actually the sum will be the seismic weight for total seismic weight, and then that's the basis for calculating the design base shear, V. So kailangan meron to lagi. And then click confirm seismic parameters. You can see na everything, the four buttons are already in green. Actually, when you click calculate, you can already generate the loads. But maybe we can just define some project details. Patrick's house, um, 001, Ellsworth, designer, PCG, Patrick, sample load, calculation, NCP 2015. So these data will be shown in the detailed report and also in the report, which is this one. So confirm. And yeah, so everything's already okay. So this one is for to request some feature. This one walkthrough. If you do not know, well, we already have a walkthrough earlier. So and I just need to click this button, calculate loads, and let's wait for the results. So in this left area, you can see the summarized input parameters. So these are the site data, the structure data, the wind data that we used, the seismic data, and here are the results on the right side. So wind pressure for windward wall, leeward wall, sidewall, windward roof, and leeward wall. So these are the surfaces. And then pressure along B. So pag dito naman yung wind load. So for reference, ang minimum dapat is 770 for uh, walls and 380 for roof. Actually, this one is being used in calculating the approximate base year. So we can see that in the detailed calculation. Actually, some results are hidden or are included in the detailed report. So it's best to use the detailed report. So you can see the all the parameters, the input assumptions, and the calculation formula inside. So you can download it as PDF or HTML. And then this one, the approximate base year. So this one is calculated para we can compare yung what to use if you want to maybe select what is governing. So, but definitely hindi na siya mahirap ngayon since may software na. So, using SVD, you can just put the pressures and then add some load combinations and then put the seismic load, add combinations, and then you can already check the worst case. No need to double check this one. But for a quick calculation or quick check, you can see the base year here. Uh, Later we'll compare. So maximum is 199. And then for the seismic load, ito yung seismic parameters. Ito yung calculated base shear. And ito yung equivalent or ito yung distribution ng forces from that. So, based dun sa approximate base shear, definitely we've seen 199 kilonewtons and 155. So, I'd say mas mag-govern yung wind kasi mas malaki yung base shear niya. And then this one is the design response spectrum. Yan. So the detailed report, you can see all the assumptions, the minimum, maximum, and then the adapted base shear based on the the formula for the design response spectrum. Yan. So best is to use the design response spectrum para ito, and then in SVD you can just import this one and scale it down using this calculated base year. So may criteria sa NSCP or sa UBC na if it is regular or if it's not regular, we can just scale it to 100%, 80 to 100% of the size design base shear. Okay, so that one, yeah. So this one, you can just import, copy paste, or in SVD, using in SVD, merong button dun sa apply loads, and then you can just import the data to the model and add it as a spectral load. And yeah, so that's how you generate the seismic and wind and seismic load using NSCP 2015 in SkyCiv load generator.